Hi there, and welcome back to the channel. Today, I'm going to talk to you a little bit about some of the infrastructure that we need to put in place in order to successfully continue working on the Telnet MUD game. And I briefly mentioned this a little bit before about having a database and having business layer objects and have them differentiated, have them separated from the actual database objects, and we do that via a mapping layer. Now, a mapping layer is just something that takes one object and translates it into another object. And what we might have here is we might have inside our some kind of database object here. And what we want to have is we want to have an object that we can pass around to whatever we need to use it, and it might have some methods on it to calculate stuff, whereas this database object is pure data. DB, here we go. And so we may have some methods that we call. We may have some enum values on here to help things be a little more descriptive and easier to read. And what we need to do is we need to have some way of going backwards and forwards to this, where we can take this object here and we can say, okay, I want you to map any changes onto an existing database object. Once we load that, and going the other way where we load something from the database and we want to translate it into this particular business object that we have here. And the way we do that is through a mapping service. And this is going to be built on the AutoMapper Nugget package. And from that, what we want to have is basically we want to have really two functions that this interface implements. And what we will do is we'll also put this into an IoC container. So we can do dependency injection, and we can also do service locator work as well. So basically that means when the program starts, these kind of services get put into, these interfaces get put into a container in their implementation, and then if you need to use them, instead of going instantiating a new object for that service, you can just go to the service locator and say, go get me one of these, which means it's very nice because what you can do is you can take out, say, a release version of a service implementation and replace it with a debug version, for instance, if you're trying to debug it. It's very useful, very extensible, and it's basically what everybody is doing today. So going back to our mapping service, we need to have two functions, and we're going to have a function that takes a destination object, and we're going to map it from a source object. And these here, this and this here, what this does is this basically says, hey, these generic types, they have to be classes, so you can create new stuff with them. And the other function that we want to have is we want to take an existing database object, and we want to then map back onto it any changes that are from any changes that we have. So we're going to do that, and what we have is we have some tests here. Now, this is the second time I have tried to do this this particular recording, and the first time I did it crashed, and so a lot of this in that one I did a lot of work on getting this to actually work. And for .NET Core, we need to install some Nugget packages, and the ones that we need are NUnit, the NUnit adapter, the test adapter, and the Microsoft.NET Test SDK. And with those installed, our Visual Studio Test Explorer can actually read out and execute these tests. It discovers those tests and knows how to execute them. Yeah, so we have some testing. So obviously this is a text fixture here. We're setting up our mapping service. We're going to be using it. We're going to be using the interface. So this is the one-time setup function, and what that does is that means every time all the tests are loaded, this function will execute only once, which is different to a setup function where NUnit can execute the setup function before executing the test. And here we have a test. We're testing the map from. I have generated some dummy data here. So we just have a source class where we have some fields here, but you can't see my mouse cursor. We have some test fields here, just some fields. And we have destination. And what we're going to do is we're going to map over to there. So what we have is from the map from, we create our source, and then we say, hey, great, go and map it to our destination. And then we just do some asserts to saying, hey, making sure that the bool field, all the fields in the destination object are the same as the source object, meaning that we have mapped this successfully. The update existing, we basically generate a source again. We map it to a destination, which is essentially this test. But then we go and modify the destination. So we're modifying that business layer object. And then we basically go remap the destination back onto the source, update the existing source, and then we just go again and run these tests. Now this won't build because we're missing some code that I want to show you guys. In order to do this, obviously we have, not only do we have these guys, so we need the service, and then of course the service is basically the thing that holds all of the providers together. So in this particular instance, the way that I have done this is, at the moment I haven't got anything, but if what we'll do is just copy this out of here, and this is our implementation for this. And basically what this is that we're holding a mapper config, it's a configuration for the mapping. This is all done through AutoMapper. We're basically saying when we create this class, we're going to populate our mapping configuration. Our mapping configuration expects this action to be returned. And then what we do is we implement as virtual functions so they can be overwritten if we ever, we can override these if we need to in our inherited class. And what we do is you're basically saying, if our source object is not null, then we say, great, cool, load up a new mapper, and then we're going to map to the destination source object. And if it isn't, we just return the default. So that's normally null. Again, update existing is we do the same thing again, but this time we're calling AutoMapper's map function to do the source and the destination. Great. There's one other thing that we need. So this is the base class. So this is the generic. All of this is the generic class because we have no idea what the destination and source are and all that kind of stuff. So we need a actual mapping service to deal with the objects that we want to have. And in this case, what we have is we basically say we inherit from the mapping service to create our own domain-specific mapping, and then we're going to say, right, the base class is expecting this function to be implemented, which then basically says we're going to return this as action, and as part of that, we're going to pass this into what's our test map provider. And you'll have providers for the different objects that you want to map. And in this case, we're going to map between our test mapping source and our test mapping destination. And we need to implement our abstract class for this. And what we're going to do is we're basically going to create a forward and reverse map. And what this does is saying the forward map goes from the source to the destination, and the reverse map goes the other way. It goes from the destination to the source. And we expect these things to be created in our provider, which is why they're abstract. And so in our provider here, what we have is we go through each of them. This is where things can get a bit tricky. AutoMapper can be a bit finicky. So what we do is inside we just pass in the mapper configuration into the base class, and in our override, what we do is we go creating the forward map, mapping from the source to the destination. So we go for each. You can get AutoMapper to basically using naming conventions to auto-generate a map, and that basically says, okay, if I have a function or a property called name in my source class, and it's called name in my destination class, and it's the same type, we will assume that they are supposed to be mapped, and you can get AutoMapper to do that. That kind of works. There are problems with it, and yeah, so the company that I work for uses AutoMapper extensively, and their convention is to do each thing that you want to map, because sometimes you don't want to map things. And what's nice about this is you can do things like, for example, if you have something that is encrypted in the database, if you have a particular field that is encrypted, what you can do is inside, instead of doing a direct map here, you can say, okay, well, we'll do a we'll call a decrypt function as we go from we'll do a decrypt function on the string field. Yeah. So what that happens is we get the encrypted out of the database. And in the mapping, we then do the decrypt. And then obviously with the reverse, we go from the destination to the source, i.e. going back to the database. We can then do the encrypt. So you can do things like that. Enums are also very nice, because they're normally stored in the database as numbers. Which represents the index of the enum, and you can then just do a simple cast, and then you get what the actual enum value. You could also do other things as well. This is something that's very versatile, very powerful. And so basically what we do is we say, okay, for the member S, that's come from string field, and I comes from int and bool, and obviously the other way around. So this is the mapping provider for this particular, for our destination and source. So now what we need to do is we need to tell the service for our test to say, hey, we want to include mapping for this one, for these two classes. Now, if you had other objects that you mapped from, then you would just say, hey, we're also going to create a new, thing map provider, and you would implement. See, I can't spell. When you guys watch me, I can't spell. And we would do that. And that basically what that does is it would do the same thing. It would say, great, we would, and you just start building up maps like this, and away you go. So our mapping tests, we can see if I've missed anything. Great. That looks okay. And then obviously what we can do, we can go to the test solution, and we could say run. And what this will do is this will run those tests. So we can see that they both pass, which is great. We also did a little bit of test-driven design here, where basically test-driven design is figuring you write the tests before the implementation. Uncle Bob talks about the red, blue and green kind of hat thing that you wear. So basically what you do is you go from a testing point of view to begin with, where you write the tests, and then the tests fail, and then you go and write the implementation so the tests pass. So that's what we have there, and that gives us a way of mapping. Inside the mapping service here, we have these two lines. These are called code contracts. And what that does is it's an idea where basically you can say, okay, in order for this function to execute, I need to make sure that this parameter and this parameter contain valid data. And the code contract basically says, hey, there's a contract between me, the guy who's providing this API, and the user of the API. And the contract says that we need to have these as not being null. And so you can get code contracts through, it's built into .NET, but I have one that I have used all over the place. And as part of this project, I'm converting some of the old framework code that I have to .NET Core. And inside here, we have our code contracts. It's called contract, and we can say it is null. And we can say, if our object is null, then we can say we throw an exception. This time it's context broken exception, and we basically say, hey, give it a message. This is why. And we have various things. We have, is not null, is false, is true, not equal 0, string is an empty, and all of that cool stuff. So that basically, instead of doing if source not equal null, yeah, you might have to go else throw, and then you essentially do the same thing again inside here with the destination object. And then if that's the case, you can do this. So these two, so this is equivalent to this, and we can see that this is much more readable than this. And also, it's kind of obvious to know, like, okay, yeah, we expect these to be not null. And that's brief code contracts. Yeah. So the next step is what I will talk about is putting this guy, because we don't use it like this. This is just a testing service. Normally you wouldn't do that. What you would have is you would have something along the lines of what you would do is you would have a class. Now, dependency injection, when we talk about IoC and dependency injection, is you build up a list of implemented, you build up a list of interfaces, and those interfaces are implemented by particular objects and services. And what happens is you have like a bootstrap function in your class. So when your program first starts up, it goes and builds up all of these. It starts putting these implemented interfaces into a container. The container is just a holder of, knows where everything is. And then what you can do is you can essentially spin up a class by using the IoC container to say, right, I need a class of type, in this case, mapping tests. And the constructor of that will contain some dependencies. And because you've put those dependencies in the container knows how to build them. It says, okay, so if we're doing a mapping service, an I-mapping service, I know that that's implemented by the test mapping service. So here's an instance of test mapping, the test mapping service. And normally that you could do something like last thing, and then inside here, what you would do is you would say, this is the constructor, I mapping service service, and then you can start using that. You would keep track of that as a private service, and then service equals service. And so this is dependency injection. Service is a dependency of thing. At this moment, we don't know what implements IMapping service. When we spin this up, we don't care. It could be implemented, the IMapping service could be implemented by many things. You could have a debug, you could have a debug mapping service that just logs, hey, we're looking for this. You may replace that with something else. And then in your bootstrap, you can just say, if we're release, then do this. If we're debug, then use this other implementation. So that's really cool. Another way of doing something is you might have a service locator where you might have something like call it IoC, and then you might have of, and we need an mapping service, and then you would do that. So what we're doing is we're saying, okay, we want to go to the container and saying, right, I want you to get me an instance of this implemented interface, and then we can start using it. This is quite nice. Dependency injection is quite good. This is a version of control because basically we're saying, hey, instead of the programmer going to tell the software what interface to use, the software goes and figures it out for itself. So we will do this. Now, been looking into the .NET Core dependency injection. Dependency injection works. Service locator stuff, I need to do some work on to figure out how that goes. And so what I'm thinking of doing is I already have an implementation of IoC and dependency injection that is based around structure map. Structure map is quite a popular DI container, IoC container. It's used by a lot of different projects. We use it at the place that I work, so something I'm familiar with, something that I have. I modified a little bit, so it has this idea of a scanned IoC interface. And so what you can do is when your program starts, it uses reflection and goes through the assemblies and picking out any objects that implement this interface, and then it says, right, okay, you go and insert your stuff into the IoC container. So that's quite nice as well. You can do, structure map has this idea you can scan assemblies and stuff like that. I wanted a little more control over what things got injected into my IoC container. So yeah, we'll show you that. Okay, so our IoC container. Before we put in the IoC container, we have to have, well, we don't have to, but it's nice to have a couple, well, a helper class. And inside, I'm looking for it now. Here we go. So inside .NET, we have this concept of managed and unmanaged resources and things like that. And so within .NET, we have automatic memory management. And what that does is there's something inside the runtime called the garbage collector, and what that does is it looks around at what objects are in use, and if they're not in use, it can get rid of them or feed them back into memory. And as part of that, we have this concept of the disposing of a particular class and of an object. It's not a class. And one of the things that we have is sometimes .NET objects encapsulate things that are outside of the .NET domain. So things like, for example, a TCP client uses a socket. The socket is built into the operating system. It is not managed by the by .NET itself. And so when you get rid of your TCP socket from your .NET program, you need to go and say, okay, now you guys can free up the unmanaged parts of the operating system. Okay, sorry about the interruption, got interrupted there. Right, so we have this idea of objects being disposed, and in order to do that, we need to, .NET has a particular pattern called the iDispose pattern, and your object will implement, there's an interface called iDispose, and your object needs to implement that, and what happens is when the garbage collector is when you are ready to get rid of the object, you call dispose on it, and what that does is that allows you to cleanly clean up stuff that is in management.net. Now, you need to pay particular attention to objects and classes that implement the iDispose. So if you are using a object that needs to be disposed, then you also need to dispose that. And the easiest way of doing that is by implementing the iDispose interface. And dispose your object. So when your object is disposed, the thing that needs to be disposed, because it implements iDispose, gets disposed. So it's kind of like, you start putting iDispose in, and all of a sudden you have this big chain of objects that need to implement this particular interface. So instead of writing the same code again and again and again to implement the iDispose pattern, I have a helper class that is an abstract base class that is called disposable. And what that does is it implements the pattern and has an abstract function that your subclass, your derived class, will implement, and then anything that it needs to dispose, that it uses, can be disposed there. So that's a little bit of background for it. So I will add that now. And it's a system thing, so I'll call it system. And so what we're going to do is we're going to call it disposable. Okay, that's great. It is an abstract class. It's a public class. We want it available from outside this assembly, and it is going to implement iDisposable, not iDictionary. And here we go. Here we go. go. Copy this in here. Now again, this was framework code, so basically what we have is this is the pattern here. We have an override. So the iDispose implements this dispose method. This also implements dispose it, but crucially it's marked as virtual, so we can override this. We're saying if we're not disposed and we're in the process of disposing, then we're going to say yes, we are disposing, and we're going to call this function. Now this function in its base implementation does nothing, but you can override that. It's designed to be overridden. And then we have another function. This is part of the pattern here. This is the thing that framework calls, and it says, okay, we want to dispose. Yes, we are disposing. This comes in here, which then calls this. And then we have this crucial thing here called suppress finalize. Now, inside, so a bit of explanation about this. I can have a class called, let's create a class called thing. I have a constructor, and this is the function that is executed when I go something along the lines of var t equals new thing. Yeah, so this function here, it gets executed when we create that. We have a finalizer that we can do that. Now, this is also known as a destructor in classic OOP, and in C++, this is a symbol that you would use for it. However, it's an override. It's essentially an override for the finalizer, and if you do it this way, it comes with a performance hit. So it's much better to implement the disposable pattern instead of doing this, because then you don't get the performance hit. And this is what this is doing here. Because we have disposed of this class, we don't need to finalize it. So we tell the garbage collector to say, no, thank you. We can get rid of that for us. So this is our disposable helper class. So instead of implementing this pattern in all of the objects that need to implement iDisposal, we just inherit them from this, and then we override this, and we get it for free. So let's add a new library, new project, class library, and we're going to call this, and we're going to put it in the libs here. What's in here? Core.data.mapping. Okay, fine. So we're going to select the folder, and we're going to call this. Is that what I wanted? Yeah, I might utils. I might call this core.ioc because that's what we do. Create that because we have core.data.mapping, so we'll have core.ioc. Fine. Make sure we are building for .NET 5. Save that. Okay. So I'm looking at my old code here. Okay, yeah, we need that. Okay, yeah, we need that. Okay. I don't need that. Okay, let's create it. So we'll change the name for this one. So we're going to call this IoC because that's what we want. It's going to be sealed. We're not going to want anything to inherit from it. Class IoC, core.ioc. Actually, this is a bad name. That's a bad name. And the reason is, the reason it's a bad name is because it's I'll tell you why in a second. Let's copy that. Because if you have a class name that is the same as your namespace, things get weird quickly, and you end up with like, why is it not working? We can call it IoC, that's fine, but our default namespace is going to be in version of control. Great, so we'll put that as version of control. Now we can see this in here. Great, that'll be fine. We're going to need some variables here, so we want them to be static. So the idea is that the IoC container is what's known as a singleton. That is, there is only one instance of it across your entire program. And that makes sense because you want it to to hang around, so you can do it. So we need to know um, so this is a flag to say, yes, we've been created, because if we try and call, this is going to have a static interface. And so if we try and call something that's, if we try and call that static interface before it's actually been initialized, then things can go bad really quickly. We need structure map as well. So let's go grab that. So we grab the packages, and we go browse, and we go to structure map. There we go. Install. And I'm sure there's plenty of, and in future, I might look at updating this to the .NET Core implementation, the default built-in implementation. It's a learning process. This is what I know. If anybody knows of good documentation on how to do a service locator within the .NET Core IoC framework, then that would be really helpful. So a lazy is a static. A lazy object, it means that instead of creating it at object instantiation time, what you can do is you can say, hey, great, the first time that this is used, then we can create it, and that's fine. So we go new lazy container, and our Lambda function to do that is new container, and that'd be great. This can be read-only as well, because we're not doing anything with it. And so we're going to want, this is going to be structure map. All right. The reason it could be read-only is because we initialize it. It doesn't mean that the container is read-only. It's the lazy loaded aspect of that. We want our constructor. We're going to say our object is created. It's true because we just created it. And then what we're going to do is we're going to have a couple of functions in here. What we want to do is the first function is we want to get something. So that's what we're going to have. We're going to have this. So this is going to be our service locator function. So we can say, hey, IoC, we're going to say IoC of I mapping service, do something. Yeah, we can do that. That enables this. And of course, it needs to be static as well. And because it's static, that's why it needs a static container. And that's why it needs this. So there we go. That's why it's static. We also want to have something. So yeah, we talked about disposable. So we need disposable here. Dispose ABLE. And the reason is that we need to dispose. I can do it. Wasn't doing it last night. I don't know why. It was being a pain in the butt. So we can do that here. Add project reference, and we need core to give us disposable, and using fixed typo. Oh, it's not a typo. It's that one. Visual Studio is having a wobbly. Okay, cool. Great. And then what we can do, we need default. This should be default to get it to build. But what we need to have is an override of dispose manage resources. And then what we can do here is we can say here, if our IoC object is created, then we can dispose the static container, the container contained in our static container. Dispose. Go, cool. So that's the disposal taken care of. That's the container, because the container implements iDisposable. So we need to do that. That's why we need to call it. Great. Now we need to have a couple of other functions, and one of those is we're gonna. This isn't the complex. This isn't the complex. Don't worry about that. So we're gonna say we're gonna register this. We're gonna register a provider, and this is a not a complex function because I called it a complex function because I didn't know what I was doing. This is the configure container function. Okay, so we're going to have that. We're also going to have, so this function here, I'll explain about it here, is if you spin up an object and you want it to insert itself into the IoC container, then you can use this function to do it. Another function that you can use to do stuff is this one here, and this basically says, right, we're going to register a function, and we're going to say, this should be T interface, not T instance. This function takes an interface, and then it takes a concrete. We'll do that in a second. And we're going to say that the concrete must be a class, and it must also be of type T interface. That's pretty cool. Now we need this other object, this enum here, and this enum basically what this does is it tells the container it's a flag. It's a flag, and what this does is it basically says, once I get it in, so it's an enum. And it basically, so we've got a singleton. We talked about a singleton before. We tell the IoC container that this concrete implementation of the interface is a singleton, meaning the IoC system will only ever create one instance of that concrete class. It'll be a one object. New per instance basically says that if we were, I don't know, so say for example you had an interface to read from a file. Your concrete class could implement that. It could be a fairly small, lightweight class, kind of a helper class or whatever. But you don't actually need it to be hanging around for your entire program's lifetime. So what you would say is you would say new per instance in this case. So that means that every time you go to the IoC container or it's injected as a dependency, it would create a new object of that concrete class. The downside of that is that if you have like a management class to deal with particular groups of lists of objects and stuff, you might want that as a singleton. Obviously a new per instance, the two, every time you call it, you get a new instance. So if you have an old one and a new one, they're completely separate. They are not the same. So that's why we have that there. And we want to pass that into here to say register provider for particular implementation of an instance, and we're going to go, right, we're going to create by default a new per instance call. Okay, I'm just looking up my implementation of this now. Okay. Right, so obviously the IoC itself is you should inject that into the IoC. So you can go instance of IoC to register a provider. So let's do that. So what we're going to do is we're just going to say, right, we're going to register a provider of this, and we're going to say the container configure for this instance. This is something that, do I want this? Yeah, let's do this in here. Yeah, okay. So an IoC provider is going to be an interface. Oh, we can leave it at blank now because this was how I implemented the scanning of the assemblies. So what we can do is we can just say this is a public interface, and we can leave it at that for the time being. That's fine. We can leave it like that. We will come back to that. Not a problem. And then this will build. And what's this one? Why is that dead? Come on. What? Show potential fixes. Not showing potential fixes. That's weird because it looks fine. So type IoC cannot be used as a primary returned. I know why. Because we need to inherit from this. So inherited classes go first, then interfaces. Okay, great, cool. Right, that's cool. Right, let's deal with the registering of stuff first. So register provider. This is the simplest one here. We want to make sure that in both cases, we want to make sure that our code contract actually, we want to say that we have been implemented. So we check that both times. In this one, we're going to say, we're going to want to make sure that our callback function isn't null, because if it's null, not a lot we can do about it. Can't really do anything. And then what we're going to do is we're actually going to configure container, and then we're going to call the static container dot value. And that basically, what that will do is it essentially does this. This is essentially this. So we get the container, we have to configure it with whatever we want to do. Mainly it's used for singletons. We might at some point come and refactor this so it automatically is a singleton. Maybe. Okay. So the next one is this one where we provide what we want to do. And in this case, what we're going to do is we're going to say, right, if our object creation type is per instance, then we're going to want to say, and the only difference is, okay, so if it's per instance, then we use this one where we say for instance, use for this interface here, use this concrete type. If it's a singleton, for this interface, mark it as a singleton and use that. And that's pretty cool. Right. I have a couple of other functions to do registry scanning, but we can come back to that at a later date. So now what we want to do is, because we have this as an IoC container, what we want to do is we want to hook that into our mapping tests. So this is what we're going to do. So we're not going to use these. What we are going to have is we're going to have a, I can't type because you're watching me. We're going to have a private IoC, yeah. And this is going to be, we're going to need to, yeah, so let's add a reference to this. Add reference. This is also testing our IoC container as well. We're going to do this, I'm going to do that. And then we're going to say, using, no, we've done that, add reference, yeah. Yeah, come on. Why that? I don't know why it does that. It takes an awful long time. And there goes my project. Yeah, well, we're here. Okay, so we're going to go, where is it? It's, no. Amazon wants to send me something. No, we've done that. Fine. Using core.io. Oh, inversion of control. Doesn't like that. Doesn't like that. Can I rename this? Let's try renaming this. Rename. Because, you know what? It's bad. Assembly name. Right. Okay. Dependencies. Dependencies? Structure map. Just build. 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 I'll go red. this is where I frown. Runtime. We don't need that. But this worked. This worked. Nope, definitely doesn't something like that. Runtime. I am. Serialization info. Let's get rid of it. It's not used anyway. I don't like that. I have a feeling that's going to come bite me in the butt in a minute. That's what I feel. I feel that. Right, that's fine. That's fine. One-time setup. Right. IoC equals new IoC. Yep. We should dispose of it as well. So one-time teardown. Turn my phone off. 1 second. Okay, cool. Yeah. Tear down. And we're going to say IoC dot dispose. Because we should call it, because it implements disposable. Now we're going to go, right, IoC dot, nope, that's fine. So we've got our new one here. So we have our static thing. Static thing is register provider, right? For our iMapping service, we want it to implement test mapping. Test mapping, no. Test. There we go. And it's going to be per call. Right, awesome. Okay, which means we don't need that. And we don't need that. What I can do is I can go private read only. I know, because it comes up all the time. It comes up all the time. Stop bugging me. Right. Now we can go I dot of iMapping service. There we go. Okay. Yeah, that's fine. It is kind of used, but it's not used through that one. No, fine. So will we build it all? No. What'd I do? Build. I said rebuild. Test Explorer. Run the tests. See if they compile. And they run. Is it going to run? No, it's not. It's not going to run. Okay, we've broken something. What have we broken? What have we broken? It says system null. System null. Obviously. Okay, fine. That's fine. We come here. This is map from. So let's do that. Let's do a debug. Let me debug this test. So debug test. Right. We have our source. Let's go to IoC. IoC. Ah, we didn't implement it. Right. Well, this is a good example of our test-driven development, because we have a failing test, so we need to fix it. So again, what we need to do is we need to go right in here. We're going to come and we're going to say we need to be created, and we're going to have a try, because we're going to try and do something. And what we're going to do is we're going to say we're going to catch our structure map configuration exception, and it's from structure map. So something that structure map throws at us. We're going to we're basically say, okay, well, we're going to redirect that, and we're going to give it something. We're going to throw a null reference exception, because that's what we're going to return null. Yeah, we can't find something, it's null. Great, can't use it. Nice, useful. It'd be nice if we knew what it was, which is great. We've certainly asked for a type here, so we can use it here. And then we're going to go return static container. I can't type. Container dot get the actual container, and then we're going to want to get instance of t, and that's groovy. That's cool. Come back to our tests, run our tests, and they should pass now. And they should pass. Yay, they've passed. And that basically means that this works. We now have a functioning IoC container. We have a functioning mapping system, which is really great. So we're on a good progress to start mapping objects. You know, it's basically from the database layer. We're getting to a point where we can start actually doing some actual stuff to get the program to actually work. This is quite an important step, because what we've done is we've built some of the really underlying fundamental classes that will be used throughout the entire system. Obviously, another one that we're missing at the moment is a logging system. There is a logging system within .NET itself, but again, you know, I have written one that I used in the .NET framework, so I might convert that. You know, you build up library code and you start using that, and everything gets built on that. And it'd be nice to convert that library code to .NET Core, which is, again, you know, one of the things that we're doing here. But this is really good progress. We have functional mapping system. We have functional IoC container, which we can use for dependency injection. In order to do that, we basically have to say you would go say, for example, your service class. You would also tell the container how to build that, and it would then go and look at all of the dependencies, and it says, okay, if you then spin up get me an instance of this service, it'll go, right, okay, this thing needs 15 dependencies, let's go and build all those 15 dependencies, and away we go. So that's pretty cool. But yeah, so this is a really good start. So yeah, hopefully it was educational for you. If you have any comments about how, if I'm doing something wrong, or if you notice anything that could be improved, go right ahead and comment. You know, I believe in, you know, continual learning, and I think this is a really good thing. So yeah, that's great. And I'll see you guys next time.